All right, let's look at this last example. Look for a GCF of all of them. There is not one. So I'm going to multiply A and C together. So this would be 6 times negative 5, which is a negative 30. What adds to give me a negative 13? So I could do, let's see, I can't do 10 and 3. I could do a negative 15 and 2. That multiplies to give me negative 30, adds to give me negative 13. So let's take negative 15 and 2 and rewrite my problem. So this would be minus 15x plus 2x and minus 5. Split it down the middle so I can take out a 3x, which is going to leave me with 2x and then minus 5. I can't take out anything here, so I'll take out a 1, which also leaves me 2x minus 5. So rewriting this problem, I would have 2x minus 5 and then 3x plus 1. Alright, so I want you to pause the video and try some on your own, and when you're ready, hit play to check your answer. So this first one here, you look for a GCF, there's not a GCF. So the next thing I want to do is multiply A and C together. So 3 times negative 25, which is going to be negative 75. I'm looking for something that adds to give me a positive 10. So I believe here you could do 15 and 5, but it would be 15 and negative 5. Adds to give me 10, multiplies to give me negative 75. And so now I'm going to rewrite this as 3x squared. Notice it really doesn't matter what order you write these numbers in, by the way. So I'm just going to write them the same order I had them written here. I'm going to split it down the middle and take out a 3x, which leaves me with x plus 5. And then I'm going to take out a negative 5, which also leaves me with x plus 5. And so now I've got x plus 5 and then 3x minus 5. Is there a GCF of all of them? No, there's not. I'm going to multiply A and C together, which is going to be 30. I'm going to see what adds to give me 17, which is going to be 15 and 2. I'm going to rewrite 15 and 2 in the middle. So I'm going to split it down the middle. I can take out a GCF of 5x, which is going to leave me with 2x plus 3. I can just take out a 1 here, which is going to leave me with 2x plus 3. So my final answer would be 2x plus 3 and then 5x plus 1. Is there a GCF? It's like screaming at you here. You can take out a 4, which is going to leave you with 2x squared minus x, and then you have to put minus 1. Remember, you got to put something so it exists. So let's use the AC method for this part. So I can do 2 times negative 1, which is going to be negative 2. I'm going to look for something that adds to give me negative 1. And so it's going to be a negative 2 and a positive 1 here. Rewrite this as 2x squared minus 2x plus 1x minus 1. Split it down the middle, 2x, which is going to leave me with x minus 1. And I can just take out a 1 here, which also leaves me with x minus 1. Now my final answer is going to be that 4 that I took out at the beginning. Don't forget about it. And then x minus 1, and then 2x plus 1. So far we have learned how to factor by just taking out a GCF. That's always an option. We have learned how to factor by grouping. Factor by grouping you do when there's 4 terms. We've also learned how to factor a trinomial when there's no number out front. Now if there's no number out front, it's real simple. It's like what multiplies to give you the last, adds to give you the middle. If there is a number out front, that is not an option. So anytime you have a number out front of x squared, you have to use the AC method. The AC method kind of trumps everything. You can always use the AC method when in doubt. Now, there are some special products that we can factor. There's something called a difference of squares. That's when there's 2 terms and these 2 are perfect squares. Now, the sum of squares. If these are perfect squares and this is addition, and you can't take out a GCF here, this would be an example of prime. There's a difference of cubes and a sum of cubes. We're not really going to be talking about these 2 in this particular class, but you will be talking about it when you get into pre-calculus. Let's talk about difference of squares, which is the big one. Difference of squares occurs when you have basically the same term here and here, but the only difference is that one is subtraction and one is addition. So think about what would happen if we multiplied this out. X times x is x squared, x times 3 is 3x, negative 3 times x is negative 3x, negative 3 times 3 would be minus 9. So what happens to these two? They're gone. 3x and negative 3x are gone. You're left with x squared minus 9. So your goal is going to be, this is going to be the problem, x squared minus 9. You're trying to get to here. So how can you recognize these as one of these special difference of squares? Well, notice x times x gives you x squared, 3 times 3, so that's a perfect square, gives you 9. So when you go to factor something like this, one of them is subtraction, one of them is always addition. So let's look for an example. There's no GCF, so you're like, oh, well, this is prime. No, it's not. If it is subtraction, has to be subtraction. Addition doesn't work. If it's subtraction and something times itself gives you this guy, something times itself gives you this guy, then it's a difference of squares. Difference of squares, I always just draw my parentheses. I know one of them's positive and one of them's negative. Doesn't matter which one's which. What times itself gives you 81x squared? Well, 9x times 9x gives you 81x squared. What times itself gives you 25y squared? 5y times 5y. So if you wanted to check your answer, multiply it back out. 9x plus 5y, 9x minus 5y, multiply those together would give you a difference of squares. Now this one does not look like a difference of squares. Nothing times itself gives you 18. However, is there a GCF? I've said it, I don't know, probably 50 times in these past couple of videos. If there's a GCF, take it out first. Ha. Take out a GCF. Now look at this guy. Is this a difference of squares? Yes. Notice I'm going to write my GCF first. Always bring it down as part of your answer. One of them's addition, one of them's subtraction. What times itself gives you x squared? X and x. What times itself gives you 9? 3 and 3. So this guy here is fully factored. Is there a GCF? Yes, there is. Take it out first. Take out a 3, which that's going to leave you with what? 9x squared, and then 3 times 4 gives you 12. Does something times itself give you either one of these? Yes. Is it subtraction? Yes. So it's a difference of squares. Draw your little parentheses here. One of them's addition, one of them's subtraction. 3x times 3x gives you 9x squared. 2 times 2 gives you 4. So notice difference of squares occurs when there's two terms here. It is subtraction, and they're perfect squares, meaning something times itself would give you either one. Just pause the video and try these on your own. When you're ready, hit play to check your answer. So let's look at these. Difference of squares here, there's no GCF. 7x times 7x gives you 49x squared. One of them's addition, one of them's subtraction. 8y times 8y gives you 64y, so those y squared, GCF here you can take out of 8, which gives you x squared minus 4. Now sometimes you take out a GCF and you're not left with a perfect square, and that's fine. That means you're done. But if these are perfect squares, I'm going to factor them and say this is x times x. This would be plus 2, and this would be minus 2. Now let's look at solving these guys. I promise you this is my last topic. Now, if you have factored and there's an equal sign, so it's set equal to 0, we can use something called the zero factor property to solve these. If it's set equal to 0, if this is x times x plus 7, that means either this guy is equal to 0 or this whole thing's equal to 0. Because anytime something's equal to 0, one of these two has got to be 0 in order for the whole thing to be 0. So what that means is I have two solutions. Either x here can be 0. I'm going to write my answer in set notation here. Now, what would make this equal to 0? X plus 7 equals 0. Well, if x plus 7 equals 0, what is x equal to? That means x is equal to negative 7. So two numbers would make this equation equal to 0. 0 would and negative 7 would. Now, what makes this whole thing equal to 0? Well, you got two options. Either this guy is equal to 0 or this guy is equal to 0. Well, let's set them equal to 0 then. 3x minus 5 equals 0. So what's my solution here? A positive 10 would make this equal to 0, so there's one solution. Now solve this as a two-step equation. Add 5 to both sides. We're going to divide by 3. So that means 5/3 would make this part of the equation equal to 0. So let's look at just some more examples of solving factored equations. If you have an x that has been factored out, that means one of your solutions is 0, because this could be equal to 0. What's going to make this equal to 0? A positive 4. So those are my two solutions. Now, you can't make 8 equal to 0. So 8 is not a solution here. So what's my only solution? 2 would make this part equal to 0. Now, let's look at this one. What's going to make this equal to 0? Negative 3. Now, you might not be able to look at this part and see what makes it equal to 0. So I'm going to add 1 to both sides. I'm going to divide by 2. So one of my solutions is going to be 1/2. What's going to make this equal to 0? So we're going to add 5 to both sides, divide by 3. So one solution would be 5/3. What's going to make this guy equal to 0? We're going to subtract 7, divide by 2. So my other solution here would be negative 7/2. So what are we getting at here? Sometimes when you have to factor and it's being set equal to 0, you have to solve it. So let's use what we learned a while ago to factor. There's no GCF, there's no number out front, so I can use a bit of a shortcut here. What multiplies to give me 25 but adds to give me negative 10? Well, I could do a negative 5 and a negative 5 here. So I can factor this guy as x minus 5 equal to 0. Now to solve it, you only solve it when there's an equal sign. So there's an equal sign, set equal to 0. That means give me an answer here. So what's going to make this equal to 0? 5. It'll be 5 for this one too, so I only have one solution. Now, is there a number out front? Yes, there is. So you can't use this method. You have to use the AC method. There's no GCF of all three of them, so I'm going to multiply 3 times negative 6 together, which is going to give me negative 18. I'm looking for something that adds to give me 7, so I could do I could do a positive 9 and a negative 2. So I'm going to rewrite this. This is where it just all comes together here, guys. We've reached the very end here. We're going to split it down the middle. So this is 3x we can take out, which leaves me x plus 3. I can take out a negative 2, which leaves me also x plus 3. So grand finale here, I've got x plus 3, and then 3x minus 2 equals 0. What makes this guy equal to 0 would be negative 3. For the sake of time, what makes this guy equal to 0? 2/3. Now, what happens if there's a binomial and it's set equal to 0? Well, always check for a GCF first. So is there a GCF? Yes. I can take out a 2x, which leaves me with x plus 4 equals 0. Now, if this is a difference of squares, wonderful, keep factoring it, but you can't factor x plus 4 anymore. That's done. I don't care if there's a number with it or not. If you take out an x, one of your solutions is going to be 0. Because what makes 2x equal to 0? Well, 0. What makes x plus 4 equal to 0? Negative 4. Now, this guy is a difference of squares. 3x plus 2. There's no GCF, but it is a difference of squares. So my two solutions would be 2/3 and negative 2/3. All right, I want you to try these two real quick on your own. When you're ready, hit play to check your answer. This guy factored into 7x minus 3 and 7x plus 3. So my two solutions would be 3/7 and then negative 3/7. This guy you had to use the AC method. So looking for something that added to give me negative 5, which would be negative 6 and 1. So this would be minus 6x plus 1x minus 2 equals 0. So I take out a 3x, which left me with x minus 2. And I took out a 1, which left me with x minus 2. So I had x minus 2, 3x plus 1. So my two solutions here would be 2 and then negative 1/3. That is it for factoring. Whew, I know it was long. If you have any questions at all, do not hesitate to ask me. Like I said, this is probably the most important topic that you need to know for this whole entire tier.